Welcome to the sixth module of LISP Your Mesh to Shape. In this module, we'll begin studying ways to mod the mesh. We'll start with the endMod function. endMod packs a lot of power when it comes to transforming drawing entities of any kind. Just like endMake, it operates directly on the drawing database through the manipulation of DXF group code values. It can offer much when dealing with mesh objects. This will be this module's objective. To see how endMod works, we can use our new tetrahedron command. Once drawn, we'll get its entity definition list with endGet endLast. Then copy, paste, and format it in a new editor window so we can inspect its values. Suppose we want to change the coordinates of the upper vertex. The original value of the C coordinate is 100. We will change it to 25. endMod receives an entity's modified definition list and transforms it as specified. The list is usually modified using the subst function. The original sublist. Subst receives as arguments the modified sublist, the original sublist, and the original definition list, which we had previously assigned to the variable msh. Pressing enter, the object is modified. Just as we modified one of the vertices, all of them could be changed one by one in a loop, creating a modified entity list that can be supplied to endMod as argument. This is the procedure we will follow to shape our meshes. As vertices are associated to the same DXF group code, we need a function that will collect all these values. We have included in the AU 2012-mesh LISP code the auxiliary function values that receives a group code as the key argument and an entity definition as the LST argument, returning a list with all the values associated to the key group code. To automate the transformation of every vertex C coordinate, we have defined the endMod-C function. This function receives a mesh's ename and a function that, receiving a 3D points x and y values, will calculate and return a new z value. endMod-Z will obtain the mesh entity list, assigning it to the end-list variable. And applying the values function, it will extract a list with all the vertices coordinates, assigning them to the vertices variable. The vertices list is then processed in a for each loop, extracting the x and y values of each vertex, and calculating the new z coordinate by applying the equation function received as argument using the x and y values for that vertex. Once the value of z is computed, the xyz vertex coordinates list is added to the vertices-mod list using the cons function. When the for each loop is concluded, the vertices-mod list is reversed to regain the original vertices order. The entity definition list will be modified in successive calls to subst. This is done in a while loop which traverses in parallel both the original vertices and the modified vertices-mod lists. When the loop concludes, all the vertices will have been modified in the entity definition list assigned to the ent-list variable. Calling entmod with ent-list as argument will apply these modifications to the original mesh. AU 2012-mesh LISP code includes 10 functions which can be used to calculate a value as a function of two variables. We'll test entmod-c with the function s02. The function name must be preceded by an apostrophe symbol. We already have a flat square mesh in our drawing, to which we will apply a transformation using entmod-c called from the Visual Lisp console. This module has shown us how to modify mesh entities using the classic AutoLisp entmod function. We've seen how it is possible to transform the mesh geometry by changing the elevation of its vertices. But to obtain a greater variety of shapes, we should be able to do so also in other directions. This is what we will study in our next module.